All right, let's do lesson 1 for calculus and vectors. And we're starting with calculus. At least today's lesson is starting with calculus. I've got a little warm up here for you that is pretty important for calculus. Let me just see what this thing down here is lighted up for. Oh, it means we're working. Oh, crap. I don't know what I did. Isn't this lovely? Ah, I'm all right. Okay, so this is pretty important for calculus. I'm going to teach you derivative rules. We'll get into that in a second. Know that everything I teach you today comes from the limits unit that you might have learned in advanced functions. And if you didn't, there is a limits unit that you can look through the lessons for on the Calculus and Vectors Google site. So anyway, the first questions I have for you are these ones, and these are movable, so I'm just gonna do them one at a time. Yes, the question really is subtract 1 from each number. So the first question, hopefully you're not having any trouble with this. 7 subtract 1, 6. I know, you're thinking it's pretty easy. A little bit more difficult. -5 subtract 1, -6. All right, next one we'll do is 3/7. So 3/7 subtract 1 is actually 3/7 subtract 7/7, because 1 is anything over itself and we need a common denominator. So that ends up being -4/7. And to do derivatives, you need to do this, hopefully quickly. And you don't need to show your work. Next one, let's do this one. -3/8 subtract 1. We'll treat it the same as the last one. -3/8 subtract 8/8 is -11/8. And the final one, I think, unless I've got some hidden, nope, the final one is -3/2. Subtract 1 is -3/2. Subtract 2/2, because we need a common denominator, and that is -5/2. So being able to do this is super handy in the middle of a derivatives question. So let's start. So this is the unit 1 for real derivatives. For real because limits really is the unit 1, but this is the first new unit in calculus. Now, I've got some rules, but I just want to list some things that are the same as derivatives. So derivative, I should have mentioned, is the same thing from the limits unit as m-tan. So derivatives is a fancy way of saying slope of the tangent. You could get asked to find the slope of the tangent, to determine the slope of the tangent. You could get asked to find the derivative, and you could also get asked to do this thing, differentiate. And that means take the derivative, which is what I'm about to show you how to do now, and relates back to this stuff. So here is the first rule. So if f at x, meaning y equals, if f at x is equal to c, where c is a constant, then the derivative, so here's your symbol for derivative with the x there, so the derivative is equal to 0. So that means if you are taking the derivative of a number, the derivative is 0. So here are some examples, and I'm going to do these in different ways. So the first way is, first of all, y equals 5. If you're taking the derivative, you need to put on a symbol that says I've done it, and it's a little tick mark. It looks like a exponent 1, but it's more of an apostrophe. And because this is a number and I'm asking you to take the derivative, The answer is 0. Next one, if I'm asking you to take the derivative of f at x, one way you can tell me that is with the little tick right there. So that says f prime at x, and I'll write all this stuff down in a second. This is a constant, so our answer is 0. And regardless of how complicated the number starts looking, when you take the derivative, the answer is 0. So now for the translation, this says y prime. This says f prime at x. Same thing with this one, g prime at x. If you ever see this, this is the same thing as taking the derivative, and that is dy by dx. So that's how you say that. And that's another notation, another way of writing, oh, I just took the derivative. And I will try to use that a couple of times. So next rule, rule number 2 of, I think, 3 for today, or 3 for this lesson, because there's many, many rules. If f at x is equal to some number times x to the exponent of something, then the derivative is you drop this number down in front and multiply it with the a, and then you take 1 off of the original exponent, which is why I gave you this as a warm-up. So, drop the exponent down in front, multiply, and use an exponent that is 1 less than the original. So I'm going to move these around a bit so I have some space. Here's the different way of telling you to take the derivative. So differentiate the following means take the derivative. Now I'm going to do this slowly, but you need to realize that you can do this in less steps if you want. So I'm going to change colors for derivatives. So I'm taking the derivative, which means I drop the 2 down in front, I multiply it with the 4, and I make this 1 less. Now, no, you don't have to go through all that work if you can do 2 times 4 in your head and get 8, and if you can do 2 minus 1 is 1 in your head, and the best answer is that. I'm going to go through these steps each time, knowing perfectly well that if you wanted to go straight to that, it's fine. So next one, take the derivative. So you are introducing a new symbol to say I did something. If you don't put this symbol on, or if you don't put anything there, that is a half mark because your communication is poor. You are taking something and making it something that it's not. And I'll show you what I mean by that in a second. So in this question, drop the 5 down in front, multiply it with the negative 3, x, and subtract 1. So that ends up being negative 15 x to the 4, and you've got your answer. So what I mean by a half mark is if you do something like this, which basically you're saying negative 3x to the 5 is the same as this, and these aren't the same. So I need notation, I need written evidence to say, oh, I know I'm doing something different, and I know what it's called. This one's a bit of a trick. I'm not going to take the derivative yet. See how I didn't put the little tick there? I haven't put y prime. The first thing I have to do for this question is to use exponent rules, which say that if I bring a power up to the numerator, I have to use a negative exponent. And once that happens, I can then take the derivative. So negative 5 down in front, multiplied by the 2, subtract 1 off the original exponent, so you get negative 10x to the negative 6. And you are totally okay to leave it like that, but my recommendation is that you switch it back to the way it came from. And this will lead you to better calculus in a bit. So negative 10, and then I'm taking the x to the negative 6 down to the denominator and making it positive. So I basically reversed what I did here in black, and I did it in blue. So all these things are y prime. This is the nicest version. This is still y. So this is my split. That's where I started to take the derivative. Next question. Also a bit of a trickster. I've got a letter in the denominator again. These rules don't work for letters in the denominator. So I have to make a switch for y, not y prime. And it means that I keep the numbers where they are. So the -2 in the numerator, the 5 in the denominator, and I'll bring the x to the 3 up to the numerator and make it an x to the -3. This is not the derivative yet. This is you arranging things so that you can actually take the derivative, which I'm going to do now in blue. And I'm going to use the other symbol. Which is totally okay. So drop the -3 down in front. Multiply it by the -2/5, x to the -3 minus 1. I'm hoping you can do some of this in your head and that you aren't completely freaked out by fractions, where multiply across the top, 6, multiply across the bottom, 5, x to the -4, and then to put it back in the form that it started with, I leave the 6 on the numerator, the 5 in the denominator, and I'm going to pull the negative exponent down to the denominator and make it a positive exponent. That is a rule. And here's a double rule. I hope you remember that a root has a little 2 in here and a little 1 outside, so that you, and this is from the logarithms unit of advanced functions, so that you can rearrange this, pull it into the top, which makes it a negative exponent, and arrange these numbers so that they make a fractional exponent. The 1 that's in front is your choice. So I'm not going to put it in. And notice how I have not dug out the blue pen yet, which means I haven't taken the derivative. So I'm about to take it now. And without the 1 there, I can drop the 1/2 down in front, leave my letter, and subtract 1. And usually I do this stuff in my head or off to the side. So that's -1/2 minus 2/2 is -3/2. So it's -1, drown my brother, over 2, x to the 3/2. And in case you want to put it back the way it came from, which is really advantageous in some questions, not necessarily this one, the 2 goes back into the hook invisibly. If this were a 1, it would be on the outside and invisible, and the 3 can go either inside or outside, but this is the prettiest version of dy by dx to continue math with, which we're not doing quite yet. So right now you're doing derivatives for no particular reason other than to use the rules. And our last derivative question from Rule 2. This is also not set up yet. It's going to be set up when I do this. So bottom number goes in the hook. And then I can dig out my blue pen. I can use y prime this time again. Drop the 2/3. Multiply it by -4/5. X. Subtract 1 from the exponent. Multiply across the top. Multiply across the bottom. 2/3 minus 3/3 is -1/3. If this fraction can be reduced, which in this case it can't be, but if it can be reduced, your job is to reduce it. I have a negative exponent on that x, so I'm going to place it downstairs as a positive exponent and then turn it back into a rational, a root. So 15, 3 goes in the hook, x underneath, and an invisible 1 sitting there, and that is my best version of y prime to continue math with, which is not necessarily today, although I do know I have an application question. So I need to take a little break because my hand's cramping up, and I will go on to the last rule for this. Now, I do see something a little bit messy, and it's this thing, so let's put that where it is. And then I'm going to pause for a sec. All right, I'm back. I hope. Shoot, I'll never know. Anyhow, so in case you hear some binging of my popularity from my phone or iPad, it is a Sunday night on the Christmas holidays, so you're not the boss of me. I can keep my cell phone on if I want to. I'm not in class, so there. Okay, so last rule for this note, not last rule overall. Calculus goes on forever, just like trig. If you have a function that is made up of other functions being added or subtracted together, not just two, but many, then what you do to take the derivative of the function is to take the derivative of the first function, plus or minus the derivative of the second function, plus or minus the derivative of the third function. So you treat it like individual questions and then just string them together like the original question was. So if there's more than one piece, if there's more than one term, then you take their derivatives separately. So here's an example. Don't know why it's red, but it's set up perfectly. No letter fractions or anything like that. So I am about to take the derivative. So y prime equals, so pretend like this is a question on its own. So drop the 3, keep the 6, keep the x, make it 1 less. I'm going to do this in my head this time. Plus, drop the 2, write the 5, write the x, make it 1 less. So that's a 1. And there's a constant, so anytime you're taking the derivative of a number, a constant, that's 0. So you wouldn't even need to write that down. So our answer for this question is 18x squared plus 10x plus 0, which I'm not writing down. The end, and there is my popularity showing again. Okay, so this one, not so nice, because I've got my little letter fraction. So I'm going to dig out the black pen, and I'm going to set this up. So this is not y prime. I am not taking the derivative. I'm setting this up so I can take the derivative. So this one will be 6x to the negative 5 minus, this one will be 7x to the negative 3. This one will be plus 1 if you want it there, x to the negative 1. So now it's set up. I get to dig out my blue pen and take the derivative. Now this time I'm going to use less steps. So I'm not going to show this stuff. I can do 6 times the negative 5 that drops down all in my head, and I can subtract 1 in my head. So negative 5 subtract 1 is negative 6. That is what you're going for. Next one requires a little bit of carefulness. Negative 7 times negative 3 is positive 21. Then x to the 1 less than negative 3 is negative 4. And don't decide on your sign until you're done the math. Positive 1 times the negative 1 that drops down is negative 1. X to the, lose 1 off of that, so negative 2. And then, to answer the overall question, I'm going to put it back to its beginning look. So there's a negative exponent on the x, positive in the basement. There's a negative exponent on the x, positive in the basement. Minus, need something to hold my brother down. Negative exponent, positive in the basement, and we're done. In case you think that's a 9, that's a 4. And the last question for no reason today is this one. All set to go. Even though this is a fraction, it's not a letter fraction. So I can keep out the blue pen and get fancy. So I am hoping that at some point you can take 2 times the 2/3 and get 4/3 in your head without a struggle. And at the same time, subtract 1. And then plus, there's a little 1 up here. So it's 1 times 5 is 5. Subtract 1 off of 1 is 0. So this answer is 4 over 3x. Do not let the x slide into the denominator. Plus 5. X to the 0 means there isn't any, so I'm not writing it down. It also means 1, and 5 times 1 is 5, and we're done this question. So, why do we do this? Well, number one, we do this so that we don't have to do all this crap using limits, which, of course, you probably didn't enjoy all the steps for. Remember that this question probably would have taken you an entire page, because you're going to have to do x plus h, and cube it, meaning x plus h times x plus h times x plus h, and then you're going to do it here, and then you have to do the whole m secant m tan to get this, which you could do in potentially 2 lines. So here's a question. We might have even done this question in limits. It says determine the equation of the tangent. Fancy way of saying take the derivative. So I'm going to write this down. And instead of doing limits, I'm going to take the derivative. So y prime. 2 times the 3 drops down, make it 1 less, minus, remember there's an invisible 1 there, so 5 times 1, negative 5 times 1, make it 1 less. So we end up with y prime is equal to 6x squared minus 5. So that is actually the slope of the tangent, because that is the definition of derivative. Now you don't need to write this down. I'm writing it down because it's a note. And this is the formula for the slope of the tangent, meaning I didn't give you an x value, so it's unknown until I do. And bam, I gave you an x value. So now you can actually do the slope of the tangent at x equals 2, and you can plug 2 in for the x, and you can do as much or as little bed mass as possible to get an answer, and then you can give me a therefore statement. I'm going to do it in black because this purple was kind of wide. So therefore, oh, did you notice? It says equation of the tangent. I'm not done. All I've got is the slope of the tangent. If I need an equation, I need a slope, I need an x, and I need a y. Well, my y is this. And usually when we have a slope of a tangent, which is actually a slope of the tangent line, we're going to need y equals mx plus b, and our y's aren't this ugly. So what you also have to do is you have to plug 2 into that to get a real live number y. So 2 times 2 cubed minus 5 times 2. So that's 8 times 2, which is 16, minus 10 is 6. So now I have my m, my x, my y, just like in limits, but way less time to do it. So y equals mx plus b. Y is 6. M is 19. X is the 2. And b is unknown. So 6 times 19 is 38. Plus b, I'm going to leave b behind. 6 minus the 38 is negative 32 equals b. Therefore, the equation of the tangent, the derivative, and it's actually a tangent line because it's y equals mx plus b, is y equals mx plus b. The end. So the stuff that is in the textbook for calculus and vectors, so unfortunately this isn't a workbook type course, it's a textbook type course. This is the textbook stuff. So 1 to 4 on page 83 to 85, number 8, and then when you get to 13, just A and B, and 14, A and B. So depending on how my evening goes, I will do my best to do another note or 2 and try to whittle this down so you have the same kinds of videos for calculus and vectors as you did for advanced functions, and get them on a Google site. Anyways, take care, and let's see if I know how to stop this thing. Stop.